So a few questions. So the first one, sensor suite. What does this look like? I'm sure there's cameras on the vehicle. Are you using radar and
Cameras,
lidar?
yeah, no lidar. Cameras, radars, beamforming microphones, humidity sensors, infrared, uh, pressure sensors in the feet and handlebars, uh, all telematics, GPS, Wi-Fi, Bluetooth, LTE, bunch of other stuff.
And how much? So there's, I know it's not 100%, but there's fairly significant overlap with similar work that's being done for automobiles, right? For four-wheel vehicles. Are you able to?
Foundationally, there's some overlap, but a self-driving car has a zillion more variables to worry about. It's exponentially more difficult.
Oh, in what way?
Well, a car has to be able to drive by itself totally autonomously without ever any input from a human. Whereas, which is, why Tesla calls their system autopilot. Quite literally why we call our system co-pilot. Our system is intended to increase your situational awareness in the case of you having autonomy to steer the vehicle or brake the vehicle in time. Now, further out, 10 years from now, we're going to get to a system of collision avoidance, but it's not going to stop at every street light and know if the yellow line just disappeared and know which side of the road to still stay on and all that kind of thing. So it's quite a bit different than a full autonomous system.
So are you able? So yeah, I would certainly agree that it's different. And then also, I mean, if you are swerving, the ability to shoot a gap is very different in a full car as opposed to a motorbike. But
right.
Are you able to leverage? So before we got where we are with autopilot and such, the automotive market went through similar, where it was, yeah, let's have the ability to slam on the brakes rather if the driver's not seeing something, or let's work on lane keep assist. Are you able to leverage anything from there? Are you guys really doing this from the ground up and developing your own algorithms and such?
Great question. It has to be done from the ground up because cars are nothing like motorbikes in the way they behave. And we tried. We took all the off-the-shelf stuff from top of the line suppliers of collision avoidance systems, and they don't apply at all. And I'll tell you why. So a car can't lean to 60 degrees. And when you brake hard, a car doesn't pitch forward and point halfway to the ground the way the forks compress at a hard braking on a motorcycle. So a motorcycle is a leaning device that takes up a quarter of the width of a lane, whereas a car is a non-leaning device that occupies largely the entire lane. And so if you picture an invisible blind spot zone beside a car, and that blind spot zone is exactly 1 lane wide, so it doesn't read a car 2 lanes over. If that was a motorcycle and it's in the far side of a lane versus the inside of a lane, that zone may bleed over into 2 lanes. And then as it goes around corners, you're going to have cameras and radars pointing at the ground, pointing at the sky. And so we have to develop all of our own unique algorithms using commodity sensors to deal with the real-time adjusting to keep the invisible zones around the motorcycle level with the ground, even though the motorcycle isn't.